Hello, my name is Ben Bowen, and I'm going to be walking you through our Pixel Pursuit Chaser game. So first things first, I'm going to teach you how to open the Pixel Pursuit game with your IDE. So first you're going to take your archive file that you have in downloads, then you're going to go to your IDE, you're going to hit File, Import, then you are going to import in the general. You're going to hit existing projects into workspace, and then you're going to hit select archive file, you're going to hit browse, go to your downloads, and then select that folder. Then you're going to click open and finish. Now that it is in your package explorer, for our particular project, to run the game you go into src, game, and then game app.java, and then you are going to hit run. It'll take a second and then it'll run. Alright, so now I will be walking you through the use cases of our game. So the first use case is the login screen and account authentication. So in terms of logging in, if a player already has an account but they enter in their password wrong and they hit login, it'll say invalid username or password. And then let's say we enter in the correct password or a wrong enter username. Hit login, it'll still say invalid username or password. And then if it ends up being correct and hit login, it will actually log in. So then the second use case, also going along with player authentication, is creating accounts. So if the player tries to create an account with a username that is already in use, then it will say username already taken. So that exception occurs when the creation of an account is not valid, but if they create a username that is not in existence already, then it will log them into that new username. Moving on to the third test case, which is, or use case, sorry. Moving on to our third use case, we have playing a run. So on this test account, say we play a run, there are 2 exceptions and 1 success of this use case. A player makes a run from a main menu, a brand new session is created with the player, the runner, the chaser, and then the maze. And on success, the runner will reach the exit with their currency collected, and a menu will pop up with you escaped. We got 3 gold, and it will update when we go to return to main menu. It will update the 3 gold there. Now, if during a run a player has to leave, they hit escape, then the game is paused and they return to menu, they will not receive any of the currency that they collected. So if, for example, there's a piece of gold right here, we collect that, we hit escape, we acquire 2 gold, 1 from being alive for 10 seconds and 1 for collecting, and we hit menu, we will not add that 2 gold to our previous 3 gold, so we do not maintain that currency, as well as the other exception or fail case where the currency and other statistics of the player, like longest run, stuff like that, does not get updated as if we get caught. So if I can catch this chaser who seems to be running away from me. There we go. I get caught. We got 1 gold for being alive for 10 seconds, so we should not see that gold add to our 3. So if we go to main menu, yes, we do not have 4, we have 3 because we did not get that gold. So those 2 exceptions of being caught or escaping cancel the play run session, and the player does not receive their currency. So moving on to our fourth use case, we have player customization, which will be hard to do on a new account with very little currency. If we hit customize, there are options of color, hats, or other cosmetics, and multipliers. And these 3 are unlockable while playing the game. And if the player does not have enough currency, it will cause an exception when you try and hit buy, and it says not enough gold. So if we hit close and go back to an account that has plenty of currency to demonstrate a success, we can unlock a color, hit buy, and then it will take our currency and equip that. Same thing for a cosmetic and for a multiplier. And then there's a selector to equip certain ones. Let's say we equip the diamond hat and a light blue color and a 10x multiplier, which updates up here. Then we go back, we can hit play, and then we have all of that on, as well as the multiplier. So then if we go back to main menu, I can demonstrate use case 5, which is a leaderboard. So in the main menu, we also have a leaderboard button that if you select, it will go through our accounts.txt, which is all of our accounts that we have on file, and it will order them from greatest to least in terms of best run time connected to that account. Now it shows the longest 10 runs, so if there are more than 10 accounts, it will only show the top 10, and then an exception for that use case would be no completed runs exist. So to demonstrate that, I will go into our accounts.txt, grab all of our account data, get rid of it. It's copied, but for now we'll just get rid of it. Then run the game again, create an account because there are no more accounts, and then hit leaderboard. It'll say no runs recorded yet. So this exception occurs when we have no runs on file and it can't grab any. So moving back, we'll put our accounts back, save, and run the game once more, and I will demonstrate use case 6, which is changing of difficulty. So if we hit the difficulty button, there is no exceptions for this use case because you can only hit hard and easy and back, and it will set the difficulty. Hard being adding a 2 times multiplier, so you'll notice earlier we had a 10 times multiplier. If we hit hard, it will change that to 20 and adjust the difficulty text in the loot display panel. And then back will get us back to our main menu. And then the last use case is simply exiting the game. If a player no longer wants to play, we hit quit and it will exit us out of the game. Okay, so now me and Lucius will be going over each individual file in the code and describing their purpose, as well as the overall purpose of each package in assembling our full game. So, first of all, let's start by talking about our accounts. So each player who plays the game will create an account on the login screen. And this player will have obviously a username and a password, and then we have 2 currencies, gold and diamonds, and the free versions of the currencies will be currency that they gain or collect in a game, which is not yet confirmed to be kept. Like if they die, if the runner gets caught by the chaser in the game, they will lose that, and then if they make it out to the exit, it will be transferred to the vault gold and vault diamonds. So I have four attributes, 2 currencies for each player. And then we also keep track of a best time that you'll see will be used later on a leaderboard. And then in terms of how we let our users customize their players, they get to equip a color, a cosmetic, which is some kind of hat or something, as well as a multiplier that they can unlock. So for each of those, we utilized an ID system for unlocks, colors being 0 through 14, cosmetics 15 through 27, and multipliers 27 through 31. And then we use an unlock mask where each digit, 0 to 31 or 32 digits, 1 being unlocked and 0 being locked, to determine whether an account has any of the cosmetics. So we have a simple constructor that initializes all these variables. We have one for testing that was used in a account manager unit test that simply requires a username and password, but that's not used during the game. And then we have our getters and setters for all 9 or so of these attributes. And then all of these accounts are stored in a account text file in game resources right here. and all 9 of these attributes are stored back-to-back separated by semicolons. So here, you're joining all of these variables together with semicolons, and then you can also split them to get each of these components. And this account.java is assisted by accountmanager.java, which reads the accounts.txt file as a path, and it loads all the accounts in this first method. And then in order to save accounts, it can rewrite to that same file. And then we have our default constructor for create account, which initializes all of these variables, the 4 currencies, the best time, the default color, which is 14, that's the ID of it, no cosmetic, and a 1 times multiplier, which we set as -1, and a 0 long, which is that bit mask for all 3 of those attributes. And then we have a login method that simply handles the username not being correct or the password, as well as an update account method that saves the account's information. So swiftly moving on, the next thing I'm going to talk about is our cosmetics. So our cosmetics, as mentioned, are 31, or 0 through 31, 32 items. And here you can see our colors are broken down, 0 to 14, cosmetics 15 to 27, and the multiplier is 28 to 31. So we initialize those as final static variables so that we can reference them easily later, and it's nice because you can reference these in other classes by just importing player cosmetics, which we'll get to later when we get to the customize window. And then we have our color table, which has all of these colors, which references a UI colors class, which takes the hex code of colors that we found to work for our players. And then we generated 15 pixelated images of cosmetics, and those pictures sit inside of game resource images, which is another package that's just filled with PNG images. So player cosmetics basically has all of these ID numbers as well as locations and names of cosmetics, and then the finishing methods are setting and loading the cosmetics, set, load, and get cosmetic, get the images from that data package, and then these 2 methods are really interesting. Some of the cosmetics are hats, and some of them are pets, and some of them are glasses. So each cosmetic has a different X and Y offset as to where you place that cosmetic on the player. So we have getters for that. And then the unlock bitmask helpers check if the player has that cosmetic unlocked. So has color, unlock color, lock color, and then has cosmetic, unlock cosmetic, lock cosmetic, has multiplier, unlock, lock, multiplier. So those 9 kind of are just to see whether the person has it, whether they unlock it when they buy it, or lock it. And in another scenario, I don't think it's ever actually used to re-lock a cosmetic, but it's there just in case. Then we have simple helpers. Has 2x, 3x, 5x for the multipliers that are easy to call in the multiplier class, because the multiplier needs, as you'll see later, is dependent upon the mode, hard mode or easy mode. Easy is 1 times, hard is 2 times, and they stack, so 2 times. And then we check which multiplier they have and which one they have activated. And then finishing off the player cosmetics file, we simply have getters and equipped methods that check what the player has equipped or what they have are using right now, and returning that, and those are used quite frequently when we're pulling up cosmetic windows. So moving on, each of these 3 files, color info, cosmetic info, multiplier info, simply have more information on the colors. So they just hold these big tables that describe the colors. They got names and prices, and it's very simple. It just has ID, name, and cost, and it just holds those, so we don't have to have all of that information in player cosmetics and have the file be really, really, really long. So color info breaks down cost, name, and ID, and then here in cosmetic info, cost, name, and then image instead of a color ID. And then we have a couple finding or getting the index and stuff like that to return information. And then multiplier, same thing, cost, ID, name, kind of thing. And then we have getters to get values for indexes and this information to put on buttons and stuff like that, and prices to return information. So these are small little helpers for player cosmetics. So moving on to the next package, we have persistence, which is our leaderboard tab. And all of these, by the way, that I've been describing will be used in Windows later. So these are the background classes that are being activated by UI windows that I'll talk about in a second. So moving on to the persistence package, we have 2 classes. The first one, very simple, is a leaderboard.java class, which just grabs leaderboard entries, 10 of them to be specific, and sorts them so it grabs them from the accounts file and sorts them by highest time at the top to lowest, and then the actual leaderboard window will grab just the top 10 and display them. So speaking of leaderboard entries, our leaderboard entry class takes in usernames and the best time, which are both attributes of an account. It gets both of those and has simple getters, and then passes those entries to the leaderboard. Very simple package. So moving on. So the next package I'll be talking about is the UI components. So throughout the windows that we use, Window Manager and then all these windows down here, we use a lot of components over again, specifically buttons, different buttons or color tiles or cosmetic tiles and selectors for the shop. So all of those can be extracted and put in this controls package so that we can simply call them when we're building those windows out nicely. So the first one is a color tile button. So this is in the shop when we're picking a color for an account, and it's a lot of cosmetic stuff. It's just a simple paint component method, and then has a cover over it when the tile is locked so that a player cannot equip it. And then an info button is at the bottom right of the screen in the main menu, and that just, when the player clicks on that, it'll display a message of how to play the game. And then moving on to our rounded hover button. This is our buttons that when you hover over them, they expand. So we used a scaling. So again, we used a paint component method, and we had to use a rounded border, which I had to look up on Google and figure out how to do that. So we used arcs and our x and y variables with subtractions to round out the button and then fill the color in it. So that was a rather complicated paint component that we had to figure out. That was a challenge. But then after that was done, we have a constructor to make the hover button, and then we had a scaling of the font. We had to make sure, which that was tricky as well, between gigantic PC monitors and laptop screens, adjusting fonts to fit the screen. And then we also had in our menu certain buttons are all alone in their own row, and certain buttons are half buttons that are in their own row, or they're sharing a row. So we have a create button row that splits left button, gap, right button. So moving on, our rounded password field. This is where you enter in your username and password. We had another paint component with, again, the rounded borders, same kind of thing, border component, and then we had a field to enter in information, and we were using colors again from that UI colors field. Rounded text field, same kind of thing. These are again going to have your paint component class, your border class, and again the subtraction to get the round, and arcs to get the rounded borders, and the text field that you're entering in. The tile button, this is another button that we used, which again has your paint component class with the arcs and the rounding, and filling that rounded button, as well as a border and a locking mechanism. This is another shop button that the player cannot set a border on if they don't have it unlocked. So with all of those buttons done, we're going to move on to the game fonts, the theme package, and it's a very simple package. It just has two files in it, game fonts and UI colors. Game fonts is just loading up the font file that we downloaded off of a free Google Fonts that's sitting in a resources package, and it's just setting it to be called from other button functions to display during the game. Just calls that file. And then UI colors, this is called in the customize. This shows we picked colors on Google, found their hex codes, and translated those into the 3-number form, and then all of those colors sit here so that they can easily be referenced throughout the game as we're building those UI components. So now that we have the theme package done, we will move on to the panels, which are the last bit before we get to the windows. So in general, we have 3 panels. So we have a basic background panel, which simply just calls an image. So again, we have those images stored in resource images. So the background, just get resource and then find the background image, and if it can't find it, print an error message and then a paint component method. The game panel, this is a little more complicated because it's not just a background image. So this one calls its own background image, but then it also calls a stone image and a gold image, and then it starts to build the actual game using those images, repeating those images as well as scaling those images to fill the grids, or the cells that will be talked about later. And then we also have a paint component class, which again you'll notice key in on this part. We have the scaling of the stones, the scaling of the gold, and the scaling of the diamonds. And this is all to make sure that as these images are being dropped in each tile, they all show up nicely. And then we're using those colors from UI. So then here we have a couple nested for loops that go through X and Y with offsets, and each cell is added one by one, and then they check, is it a wall? Does it have gold? Does it have diamond? And it puts the appropriate images into those cells. And then we draw the entities. So here's drawing chasers and then the players. So here we have a small direction method that handles WASD, the arrow keys, and it simply sets a direction to be called and handled in the gameplay packages, and as well as our hat and glasses and pet methods here at the bottom that just, when you're building the game panel, it just calls those cosmetic classes the cosmetic info, and it gets the information for each cosmetic in order to display it properly when it's building the game panel. And then our last panel in this component panel package is the currency, or currency and time panel. So that this panel has two different forms. In the lobby, it will have the player's currency that is stored, so vault gold, vault diamonds, no time. It just has those two, as well as it'll show the multiplier and the difficulty on a second line. Inside the game, it'll show the free gold and free diamonds, meaning the currency that they could lose, as well as a little timer. And in this one, we're calling images here, again, for vault gold and diamonds, or gold and diamonds, as well as a little timer image to display those numbers, and then we call the font as well to sort of build a little panel. And then first row, we have our icons and our amounts. This is where we call the attributes of the player or the game session, depending on which version is being built. Then we have our loading icons, which takes the icons from the images. And then we have our, as the player acquires more gold or diamonds during the play session, we now have to change the game panel in the top right corner very frequently during the game. So we have our setters and update methods that quickly change the info in the panel as the game is going, as well as we have a set multiplier and difficulty, because that changes when you hit customize. And if you select a different multiplier, or you hit difficulty and select hard or easy, the multiplier changes, and obviously the difficulty changes if you change the difficulty. So those need to update as that window opens and closes. So this panel is constantly being updated, so these methods at the bottom here, the helpers, are really important, as well as building the panel in two different kinds, whether we're in the main game or the lobby. Now that we have those panels out of the way, we can move on to the last little bit here, which is the main part of the UI, and we'll start in the window manager. So the way we chose to do the UI is through a window manager that takes in our current account that we're logged into, and we start with some getters with the current account. We also have a show window method, which displays each of the windows as we call them, and then here we have our public window API. So these are going to be all your window classes right here. When they're clicked on, the window manager is called, and it will display a new version of these windows, or call the windows if we're switching main windows. So our login, our main menu, and the game window, these are our main windows that open a brand new window when you click a button to get here. And then these leaderboard, customize, and info windows are just pop-ups that you close out of, so these create new windows instead of switching windows, which is a key thing to know. And then obviously when we have, as I discussed just a second ago, when we are clicking on these customize and difficulty and stuff like that, when we're clicking on those kind of windows, we're updating whether it's the currency or multiplier or other stuff with the account. It's really important that you update it and refresh the loot window so that everything's up to date as you're moving and navigating through those windows. And then we have a simple exit game. So let's get started. The first window I'm going to talk about is the longest one, customize window. You're going to have to bear with me. I'm going to go through this fast. It is the longest file in the game. So the customize window is a scrollable window, again, broken down into three categories: color, cosmetics, and multipliers. So a lot of this was factored out into the different button classes in our controls here, and it uses a lot of those buttons and calls them for organization. It was really nice to clear out most of those methods and move them into other classes and then call them. So we were able to kind of keep it condensed, even though it is quite an advanced window. So this one took the most amount of time, so bear with me, I'll try and get through it. So here we go, we have our constructor that builds the customization window. So we got our title, we got our background colors, stuff like that, and then we build a scrollable plane because we want it to make sure it works on every single monitor, regardless of size. So we make it a default size, a small default size that doesn't show everything, and then we have it scrolling. And then we have our simple text, and then here's the colors section. Again, we call those colors from the UI colors. That part was taken out earlier, which is nice, so we just call those colors and add them, each with their own label. And then we're able to add those kind of buttons later on. We'll see that. The cosmetics section, we're able to add a selected label. There's also a selected label up here on colors. So we have all of our cosmetics in a selector, and then we go through all the cosmetics and add those, each with their own selectable cell. Same with the multipliers, selected, go through, add a cell for each multiplier. Then we have a back button, which is one of our rounded hover buttons that scales as you hover over it. So that was nice. We got to call the hover button and build that. And then we have our initial highlights. So this part was a little tricky because when you have to be careful when initially highlighting buttons in the shop, because whatever's highlighted, it assumes the account has unlocked it. So we have the initial selectors over a default color, over a blank cosmetic, and then we actually wanted to keep the shop even, so we have no highlighter over the multipliers to start, which was a little trickier. And then we set that whole window that we just built to visible, and then we just kind of get into the helpers here. This is for the labels. We have those three, section, detail, and separator, which is nice. It just helps the selector move and highlight only one at a time. For the color helpers, this is just a color button, which again, with the rounded edges, it was a little hard. We had to go through and create a sort of tile that has the button as well as the cost underneath it. There's it calling the gold image to put next to the cost, or owned if the player already has it. And then when it's selected, it'll show selected and have a selector border over it. So here's the set selected border. And then this is our cosmetic cell. Same kind of thing with the selector. If it's owned, it'll have the selector cell if it's selected, and owned if it's bought, and then gold and the price if it's not. Same kind of thing with buying. We have spending gold or diamonds depending on what you're buying, and those kind of blocks. And then lastly, for the cosmetic icons, same kind of thing. And then for the load cosmetic icons, these are just grabbing those images and then loading them onto those tiles. The create multiplier cell, this is the last cell, exact same format as the other ones, with the button as well as the price and the image all together. And then here we inset selected multiplier border. Alright, and then we highlight the selected multiplier. And then here's our buying method, which just creates our new window that says, are you sure you want to unlock this, and spend the gold. We create two new hover buttons, buy and back, just in case the user wants to go back. And then confirm, and this actually spends the gold, sets it to unlock, and changes that tile, changes the dimensions, and sets it to owned instead of the price. Then we have just a couple unlock helpers to help when the player buys something. So I know I went quick, but hopefully you got all that. Moving on to the next window, we have a difficulty window. And the difficulty window is a simple 2-button window. You click on it and you click on either easy or hard. So in order to do that, we have our constructor with settings, and it says select difficulty, and then we have two options, easy or hard, and we outsource a lot of the work to creating new buttons from our button classes. Here's the rounded hover button here, and here as well for back and set difficulty set once we change it, stuff like that. And then we have a small helper that creates the panel that we're setting these buttons on. So next, the leaderboard window is very similar with the same dark kind of style. So we use the same kind of initialization. We create a new leaderboard window, just a small little pop-up, and this one will call those leaderboard entries and then sort them longest runs, and then it'll go longest to the top 10, and it'll label all of those in a simple minute seconds format. And then we use a format helper to format that leaderboard. And then moving on, we have a game window, and this game window changes from the main menu window. It closes it and opens up a brand new game window, which will pull that background image for the game. And then we use the game panel to set up the board, a class we went over a while ago. And then we have to grab the colors. So we grab a runner color, their cosmetic, and we kind of set up that player, and then we set up the chasers. So we have to set up the chasers where they are on the map. And this is all from the game logic, which Lucius will discuss in a second. We have our simple getters and setters, and then we have our exit conditions, which is when the runner reaches the exit, or when the runner dies, or there's a pause, or anything like that, as well as updating the loot panel in the top right corner as the game's going. So at the end, we do have another similar little window kind of embedded here that doesn't have its own class, and that's just the end screen, which is basically a long string that will have our gold based on how much time you were alive, plus how much you picked up on your run, and times the multiplier, and then how much diamonds you picked up times the multiplier, and then your totals. And then so those, it'll give you a nice little condensed summary of what you got during your run, as well as give you options to play again or return to menu, and again we're calling those button classes, and setting size and heights and stuff to make sure that it stays on the screen. There's our time formatting again, just to make sure when we're giving them gold for their time that it's set up nicely, and then we have a multiplier call to make sure that we're getting the right multiplier when we're building this end of round screen. Okay, so next, the Info window is a small little info button with an eye on the bottom right in the main menu, and this is simply just to display some dialogue. We're setting up the same kind of dark menu, small little square layout, simple J panel, nothing crazy with a back button, rounded hover button that says close. Nothing crazy. Next, we have our login window. So this is where the game starts, and this one will use our login background image, and then it'll set up the buttons. So we have this is where we are using the text fields. So users have to enter their username and passwords. So we set up those fields right here, text fields, that the user can enter in their information, and then we had to change it to a smaller label font because it wouldn't fit on laptops as we were designing it on PC monitors, so we said. And then we had to do more layout math to make sure that it all fit. It's kind of small stuff here and there. And then here's a simple build layout of the menu. We have a username row, a password row, and then our login or create account, depending on what you're doing with your username and password, whether you're logging in, and then a nice simple exit button. So then we have our listeners to act when a user clicks the button, and then we have our handling logic, which just makes sure that if they're logging in, creating an account, it calls the right methods and classes with the information provided, and then we want to make sure that we're opening the main menu once they create an account or log in. Then we have some simple styling helpers with rounded hover buttons and all kinds of stuff to make sure it looks nice. And then for our pause window, which I'll go over really quickly, it's just a very simple pause window that has resume or go back to the main menu. So we're just creating two little hover buttons on the same dark panel background that we've been using this whole time, and it is triggered using the escape key. So we have a lot of our listening for an escape key, and then that'll just call a simple pause window. Okay, so the main menu, last one here. So the main menu class has a menu of buttons here. So we're going to call the menu background image, and then we're going to call that loot display the menu version that has their stored loot, as well as their current multiplier and difficulty, which does get updated as you customize it. And then the center menu. So the center menu has pretty much every other window connected to it. So we have two types of rows. We have a full row and a half and half row. So play button here, full row, then customize on the left, difficulty on the right in row 2. Same thing with leaderboard and sign out, and then quit. And so these kind of call every other window. So we have our listeners down here. So if you hit quit, exits the game, sign out, goes back to the login window, play button goes to the game window, and then customize opens the customize window, settings opens the settings window, and then leaderboard opens the leaderboard window. So that's really important, the main menu, because it calls almost every other one using the buttons. And then, like I said, if you go to difficulty and you change it to hard, it's really important to refresh the loot display so that multiplier updates. All right, and with that, our UI is set up. We have our buttons, we have our colors, we have our account, all those variables. The runner is set up with everything they need, and all the buttons are hooked up, and it's time to hit play. So I'll pass it over to Lucius, who will talk about everything to do with the game once you hit play.
Hi, my name is Lucius Casertano. I'm gonna talk through a little bit about what I did for this project, which was a lot of the behind the scenes logic. So that includes the difficulty, the scoring, the gameplay loops, and then what I'm gonna start by talking about, which was the maze and randomly generating the maze and handling all the different cells within the maze. So let's take a look at cell.java first. Alright, here's cell.java. So every level in Pixel Pursuit is a grid-based maze, and each tile in this grid is represented by a cell object. So it has its x and y coordinates here, and then a boolean called walkable, which basically determines whether it's a floor or a wall, if you can walk through it or not. And then there's different loot that can appear on each tile. That could be gold, that could be a diamond, and then entities, which can be either the runner or the chaser in this case. And we can expand this later if we choose to, but for now it's just the runner and the chaser that are possible entities that could be on a cell. Alright, so the constructor sets the coordinates, the walkable boolean, and this gold, as well as this diamond. And then we have a few simple setters and getters, and this continues for the rest of the file, just basically setting and getting in very basic methods that deal with the entities and the loot and the coordinates and walkability of each cell in a grid. The next file is maze.java, which represents the entire grid of cells for a level. So it's storing the width and height and a 2D array of cell objects, and then it tracks a single entrance and exit coordinate, which the player has to reach. So in the constructor, we're basically setting this cell array as everything walkable, everything is open, and we're instantiating all of these height width values, and then we can choose between loading a random preset from the mazes.txt file or generating a random layout. And right now the functionality that I've chosen is to do random layout, but I can change this in the future. Down further, we have basic getters for all of these attributes, and then we have a few different methods to deal with the text file. So this find mazes file tries to locate mazes.txt. This was used a lot for debugging, and there are a few different choices here depending on where exactly the mazes.txt is located. And then there's a method for loading a random preset. So basically that is going to use the random number generator to load a random maze line from the text file, or just fall back to the random layout. And then it also calls this apply map line, which basically converts the ASCII to a grid, to a map. There's a generate basic layout that we were using to begin with that I kept in here, which basically is just a very basic version of a map that we don't really use anymore, but it's kept as a failsafe. And then this part of the project gets really interesting when we start talking about the random generation of the maps. So the main function here is the generate random layout. So this deals with a few steps here. So first, it sets everything as a wall. So basically, when we do go through and create the maze, we're going to be converting things from walls to floors where the player can move through. So we set everything as a wall. We create an outer border and then make sure that the entrance and exits are open and have open spaces in front of them as well, so the player can always reach them. And then we call a few different other methods here, which are carve maze, and that's a depth first search, and I'll go through that in a second. And add random loops, which kind of helps to make sure the maze isn't just one path. It opens it up a little bit. And then soften walls, which basically favors the right side a little bit and does a similar thing where it opens up the maze a little bit, so it's not as restrictive. So the carve maze depth first searching method right here starts with a directions 2D array here. And that's 2 cells in each direction, so we can leave walls between rooms, and we're not opening it too much. So we're basically looking in each of these directions and setting a new x and y coordinate, right? And we're going to find one of these, and if it's in the grid, so if it's able to be reached and we haven't gone through it before, we're basically going to carve our way to that new cell. And so we get to that new cell, we set it as walkable, and basically we're carving a path here recursively. So we're going to call that on each cell in all of these different directions. So the overall loop here is you're standing on a cell, you pick a random neighbor that's 2 cells away, you break the walls between those, and then you recurse from that new cell. And so basically, if we go back to the random layout generator, this is being called for each cell. Basically each cell that we can find, and once it's visited, we ignore it after that. So by the time that this recursion fully unwinds, we've generated a tree of corridors. So every reachable interior cell has been visited once, and there's at least one path from the entrance side to the exit side. And the other helper methods here make it so that it's almost impossible for there to be only one path. It's very likely that there's many paths. And I'm just going to go quickly through these other helpers. So there's a shuffle directions, which basically uses the random number generator to shuffle which direction we're going in to randomize that. This add random loops, and as well as the soften walls, they behave very similarly. So they're using probability to favor, at least the soften walls is favoring the right side, and the left side is just randomly determining where it should set things as walkable, where it should open up the map a little bit. The key thing here is that you're checking in each direction, like incrementing x or decrementing x by 1, and same with y. You're checking if they're walls or not, and that determines the amount of open neighbors, I guess, a cell has, and so that determines how open we want something. And that's the basic logic here, and then at the end we have a few very basic helpers of clearing entities, which happens at the end of a run, and clearing the gold as well. Now that I've talked about cell and maze and how they define the game world, I'm going to zoom out a little bit and show how we tune the game, tune its settings, its chaser count, the spawn rate, the multipliers, and how we tweak all of those values. So the first file I want to talk about is difficulty. So this class basically, we've implemented an easy difficulty and a hard difficulty, so this class just stores those basically as an enum. And then, there's very basic getters, setters, and a toString method here. And most of that, the rest of that logic is implemented in a game config file. So game config is the central place here where we're tuning all of the gameplay constants, all these numbers. So it gets the difficulty that's been set, chosen by the user, of course. And then it defines a lot of static values here. So all of our mazes are 36 by 18. We thought that would be the fairest, and it fits the best on a laptop screen as well. And then we decide tick rates here for spawning, for movement, multipliers for the different difficulties and whether or not you die, the values, and then let's go down to the methods. So the first method here is basically the main difference between the difficulties. So the hard difficulty has 2 chasers, while the easy only has 1. And we were tuning this a little bit and decided that this would be the fairest. And then we're also getting different detection radius. So in hard mode, the chasers can detect you from 4 blocks further than in easy mode. And then the spawn rates have also been tweaked a little bit. The gold and spawning are both higher in a hard difficulty map. So, in summarize, the settings package here that includes difficulty and game config creates a difficulty enum to represent easy versus hard. It centralizes all the tuning and game config, and then it exposes all these helper methods that other systems use for like chaser count, detection radius, loot spawning, multipliers. So basically, this makes it so that other files like runner, chaser, session, scoring, they can just call game config instead of hard coding these values. Now I'm going to move into the gameplay package. So this is where we define how the player and enemies move and how a single run is simulated over time. So first, let's go to runner.java. So the runner class represents the player-controlled character moving on the maze grid. So the runner lives in cell coordinates x, y, and we only care about which cell they're on here. Rendering it in the maze happens elsewhere. So it keeps a reference to maze, it stores its current XY coordinates, it tracks if it's alive, and then we basically, once it's created, we validate that the starting cell is in bounds, and then we register the runner with that cell, so the world knows the runner is in this cell. And then movement in this game is based on a glide mechanic, so we have the current movement direction, dir X and dir Y here, and then we have the desired X and Y direction, so that the player wants to move to based on the keyboard input. So the basic idea here is that once you start moving in a direction, you keep sliding that way each tick until you hit a wall or you change directions because of a keyboard input. So we have very basic setters and getters here that deal with all the attributes I mentioned before. And then the most interesting one here is the update method called step. So step basically, we do two things. So we try to switch to the desired direction if it's different from the current direction and it's a valid move. So this basically lets the player like press the button they want to go to before there's an intersection, which means that it's a little bit smoother in my opinion. And then we move one cell in the correct direction if we can. Otherwise, if we're pointing into a wall, we stop and set the direction back to 0, 0. And then we use can move and move by methods, which I'll talk about next. So the can move method basically just checks if the target cell that a player is trying to move their runner to is inside the maze and it's walkable, it's not a wall. And then next, the move by method updates which cell the runner is in and removes it from the old cell's entity list and adds it to the new cell each tick. So overall, the runner class is responsible for a runner maintaining its position, implementing the glide movement, and respecting the walls and bounds of a maze. Alright, so next we have Chaser. So Chaser is the enemy unit in this game that tries to catch the runner. So it follows basically the same rules as the runner. It also lives in the maze grid. It has XY coordinates, and it also, the difference is that it references a Chaser AI object that gives it instructions on where to move. So we have a very similar constructor as the runner class, basic getters and setters for the attributes, and then we also have an active flag that determines whether it should be active in the session or not. And then the key difference here is an update method. So each tick is basically getting instructions from a different class Chaser AI. So overall, the Chaser class is a small wrapper based around getting a position, and then an active state, and then movement that's driven by this Chaser AI class that I'll talk about next. And this move by class is basically identical to the runner one. Alright, Chaser AI here is basically, it's just an interface that defines the AI contract. So the idea is that the session calls this, and then the AI implementation looks at the state, it looks at the positions, and then it calls Chaser methods. And then the real logic for these AIs happen in a different file, simple Chaser AI. But this interface here means that we can add complexity to the project by swapping in different enemy behaviors, maybe one that can track you from further away, or one that's faster, or just different behavior that we can add if we wanted to. Alright, so simple Chaser AI.java is our actual implementation of Chaser AI for this game. So it has two main behaviors. When it's far from the runner, and that depends on the detection distance, but when it's outside of its detection distance, it roams the map, and it's biased towards areas that it hasn't visited much. And so it basically gets a target cell, and it moves to that cell. And if it's not interrupted by the player, it will reach that cell, and then it will get a new target, and it will keep roaming in this pattern. So this is the roam behavior, and then when it's close to the runner, it will switch into its chase behavior. So it's using its breadth first searching, pathfinding, to walk around walls, and basically it finds the shortest distance in the grid. It's like a Manhattan distance, which is like the sum of the legs of a right triangle. It basically finds the fastest path to the player, and chases them until the player leaves their detection radius. So that's the main overall idea for this. So we have an update method here that its entire goal is basically to get the maze and the runner from the session. It computes the Manhattan distance, and if that's small enough, depending on the chaser's detection distance, we go into chase mode, and otherwise we roam around the map. So in chase mode, we clear any roam targets so they don't have instructions to go other places, and then you call a method called move along shortest path, which basically does a breadth first search from the chaser's position to the runner's position. So it explores walkable cells in a fixed neighbor order. It reconstructs the shortest path by storing parent pointers, and then it applies just the first step of that path, and then by calling chaser.moveBy. So this means that the chaser can navigate around walls instead of the problem that we were running into early on, which was just getting as close as it can to the player, which meant it would sometimes get stuck on walls and the player would be on the other side. And then if this search fails for some reason, it falls back into a random walk, which is a different method. And then in roam mode, so the chaser isn't directly chasing the runner yet. It chooses a roam target somewhere in the maze. This is biased towards cells that have a low visit count, and this also uses random generation to help randomize the target. And it tends to explore the new areas because of this bias towards low visit count. And then we use the same breadth first search routine to move one step towards that roam target. Basically, it's choosing the fastest path there, or the shortest path there, I mean. So we have this visit count array for each AI. To determine which cells it's visited already, we pick a roam target, we try up to 80 different positions, 80 random positions, and we pick the walkable cell with the lowest visit count. And this also sometimes favors more distant cells. And this basically is preventing the chaser from just pacing in one area forever and kind of stuttering, which was happening in earlier implementations of this. And then one thing I haven't mentioned yet is the roam path lifetime. So this basically, as well as roam steps remaining. So this means that a roam target isn't permanent. If it's taken enough steps, or if there's enough time that's been passed, it will get a new target, and this kind of makes it a little bit less predictable, and just adds some dynamics. So overall, this simple chaser AI gives us enemies that wander the map and avoid over visited areas, and once it's close enough to the runner, it switches into a chase mode that hunts the runner and finds the shortest path to them. And then the final class inside of the gameplay package is Session. So Session is the core of a game run. It owns the maze, the runner, the chaser objects, and then it has all the runtime stats, which include like time survived, gold, diamonds. So we're tracking the elapsed time, the gold, and this is split into gold that you get from just surviving and from pickup, and then diamonds, and then a running flag, which stops updates when the run ends. So there are basic getters and setters here, and then the most important part is the update method. So in the update method, we're advancing the clock, so we're keeping it ticking. We are awarding survival gold, which accumulates over time. It also handles pickups, so if the runner's cell is the same as the cell also has gold or diamond in it, we remove the gold or diamond and we give it to the runner. We move chasers at their own pace, which is determined in the game config file, and then we also spawn loot, and then check collisions between chasers and runners, which would end the game and would kill the runner. So this is basically the brain behind the game, behind each run. So that's the entire gameplay package. It determines the player's movement with a runner, the enemy, which is the chaser, and the chaser AI logic, and then the session, which ties everything together. Next, I'm going to talk about the scoring package. So this is where we turn the raw session stats, like time survived, gold collected, into a final payout at the end of the run, and we display it to the player. So to begin, multiplier.java basically determines the multiplier for your stats. So it stores a value. For example, 0 if you died, 1 if you escaped on easy, and 2 or higher if you escaped on hard, or have bonus multipliers equipped, and those can be bought in the shop. And then it has get value, which returns this double, and then adds int, which rounds it to an integer for display in the UI, because we don't want to be displaying a lot of decimals there. If you die, your multiplier is always 0. If you escape on easy, the base multiplier is 1. If you escape on hard, the base multiplier is 2. And the whole idea here is that our final value is our base one that we've collected from the run stats times the multiplier. Alright, the next file we have is score system. So basically, score system is the class that converts a session into these rewards. So it's just a helper that computes this. So we have a few versions of compute, one that just takes the session, the difficulty, and the escaped, and determines the final values, and the other that takes the account multiplier, which is determined if a player has bought like a multiplier from the shop. So we determine the final values based on, of course, the base value, and then gold has gold over time as well as what you've picked up, and then at the end we're multiplying by this multiplier from the multiplier class. And so then we determine a final value for all of this and construct a session result object with the final time survived, the gold, the final diamonds, and the multiplier, the difficulty, and the escaped, and that becomes one object. And finally, we have session result.java. So that's basically a data holder for everything we care about at the end of the run. So everything that we just computed in score system, it stores like the time the player survived, the gold they got from survival, gold from pickups, and then the base gold, the final gold, the diamonds collected, the final diamonds, the multiplier, difficulty, and the escaped boolean, whether or not they escaped. So this is importantly used in the UI, especially at the end of the game when you're displaying to the player how their run went and everything that they collected and whether they escaped or whether they were caught. So the scoring package basically separates the gameplay logic from the scoring rules, so we can kind of tweak how the points are calculated without touching the gameplay logic.